today we're talking about writing our quotients with mixed numbers. We've already done some of this where we end up with our whole number answer, like how many whole times the divisor goes into the dividend, and then we take that remainder and turn it into a fraction. The whole thing together looks like a mixed number. So here is our first example for today. It says, if two children share 5 dumplings equally. Do y'all even know what dumplings are?
Yeah. They're the little pouch.
Like doughy, like pouch things. Yeah, like pork or chicken. Okay. So if two of you in here share 5 dumplings equally, that means that you're each going to get, yes, because you're going to have to cut one.
But I will not eat.
You're going to have to cut one of them in half so that you'll have the exact same amount. So how many dumplings will each receive? Well, if I take the 5 total, divide it by 2, then I'm going to have 2.5. Now you guys can picture that. It's a small number, so you can do that in your head. Okay, pretty simple. I know 2 goes into 5 2 whole times. The multiplication part of divide, multiply, subtract, bring down, blah, blah, blah. Okay, but I have 1/2 left over. Remember, this remainder becomes your numerator, and the divisor is my denominator whenever I'm writing my answer as a mixed number. If 2 people share $5 equally, what amount of money will each person receive? $2 and what? Yeah. Okay, so this is similar. This is similar to the question we just did. If you think about $5 and you take 5 $1 bills, okay, I can't split that equally. I would have to take one of those $1 bills and do 4 quarters instead so that I could then equally distribute the same amount of money to both people. So it would be $2.50. 2.5, when we talk about money, is $2.50. Okay, is everybody on the same page with me so far before we keep going? Yes.
When are we going to do square roots?
I don't know. Whenever it shows up. Okay.
I did those.
Here's a practice problem. If you want to use your whiteboard to do this with me, you may.
I'm doing it.
The more you do, the better you get.
That hurt.
Okay, 50 divided by 3. First, how many whole times can 3 go into 5? 1. And then I'm going to multiply. So 3 times 1 is 3. I subtract, and then I bring down. Now I'm dividing 3 into 20. How many whole times can 3 go into 20? 6. 3 times 6 is 18. So I subtract. I have nothing to bring down. The remainder becomes my numerator, and the divisor is my denominator.
Oh, that's easy.
So 16 2/3 is my answer.
I can do that. Sammy, I can. Oh, no, you can't.
Okay, let's do some more practice. Keep your whiteboards out if you're doing it with me. A 15-foot long board is cut into 4 equal lengths. So how long is each length? Okay, how would I set this problem up? What's the dividend? Yes, okay. Ainsley's showing me this. Does everybody agree? See or no? Yes or no? Yes. Okay. So 4 goes into 1. Oh, that doesn't work. So I'm going to look at the 15 as a whole. How many times can 4 go into 15? 3. What is 4 times 3? Okay, I subtract. I have nothing to bring down, so I'm looking at what I have here. The remainder becomes the numerator, and the divisor is the denominator. So my answer is yes. 3 3/4 what?
So you can automatically write the board or whatever.
Feet. 3 3/4 of a foot, or 3 3/4 feet.
Feet. That would be a lot of feet.
Okay. Our next example. How many? Listen carefully.
Easy.
How many inches long is each of the 4 boards? How many inches long is each of the 4 boards? Explain your thinking.
I don't know. I got it.
Okay, well, let's think for just a minute.
Wait, I know.
If each board
48.
is 3 3/4 feet, okay?
36 and...
First, we know that there are 12 inches in a foot, right? So I'm going to take 3 times 12 to get 36 inches, okay? So we're there. But we need to think about 3/4 of a foot.
3 and 9/12.
How are you getting 9/12?
Bryce had his hand up, by the way.
Bryce, can you explain your thinking?
So I did 3 times 12, and then I divided 12 by 3, which got 4, and then I added them together, and I got 40 inches.
You got 40 inches. Okay, so where did you get the 4 to add to the 36?
From dividing 12 by 3 and the 3/4.
Okay, so he's taking 12 inches. We need to know what 3/4 of the 12 inches is equal to, right? So let's draw a picture. I'm going to split this up into 12 pieces.
15 feet.
Boom, boom, boom.
That's way longer than football.
Okay, so right now, if I were to just have 3/4, that would look like this. And then I have here, and I have here, okay? So 3/4 is going to be all of this, and all of this. But if I'm talking about inches, do you see the black lines up there? How many black little sections do I have? 12, because how many inches are in a foot? 12 inches, okay? If I had 3/4 of 1 whole foot, how many inches is that equal to? Look at my shading. I have 3, 6, 9 out of 12 inches, right?
So I was right?
You were right. But does everybody visually see and understand how that works?
Yes.
We talk about a foot first. We're going to represent 3/4. That's representing 1 whole foot. We know that 12 inches is equal to 1 whole foot. So if we break up that 3/4 into 12ths instead, then you can see that I have 9 of those 12 pieces shaded. So instead of adding 4 inches, what do I need to add to 36? I need to add 9 more inches because that's representing 3/4 of a foot. Okay, is everybody following me? This can be tricky. Oh, I'm worried. Some of you are just doodling and drawing. I don't know if you're paying attention.
Not me. I don't even have a whiteboard.
Okay, this can be very tricky. I want to make sure everybody understands how this works. Why 3/4 is equal to 9/12? Does everybody understand that part?
Yes.
Does everybody understand my visual here? Okay, then does everybody understand why I am adding plus 9 to the 36 inches, which remember we took the 3 times 12 because we're converting it from feet to inches. So 3 times 12 is 36 inches plus 9 more inches. So what is my final answer going to be?
36 and 9/12 inches.
But I want it all in inches. So I'm going to add 36 plus 9 to get what? 45 inches. That's my final answer. Okay, here's our last practice problem for the day. A group of 4 friends collected aluminum cans and received $21 from a recycling center for the cans. Each friend received an equal share of the money. Which quotient represents the number of dollars each friend received? So I have 2 problems. Okay, I take $21 divided by 4. Can a friend receive $5 remainder $1?
No.
Or can they get 5 1/4
Yes.
dollars? So why would we say that this is a yes and this is a no? Can somebody explain their thinking on that? Mm-hmm.
Because, like, with money, like, if you're using, like, the parts of it,
you wouldn't necessarily want to say like remainder of one. You'd want to say like, so 1/4 would be like say 25 cents of it.
Yeah, very good. With money, it's important to know how we're breaking that money up. Are we breaking it up into fifths so that it's 20 cents, 40 cents, 60 cents? Are we breaking it up into fourths so that it's 25 cents, 50 cents, 75 cents? Are we breaking it up into tenths, 10, 20, 30? It's important to understand what our denominator is when we're talking about money. So with remainder 1, I don't really know what is that representing 10 cents, 20 cents, 25 cents, one what? One out of how many parts of a dollar? So I want to use this one here. And like Lexi said, when we have 1/4 of a dollar, it's like having a quarter. So it'd be like $5.25.
Knew it.
And then how do we write that amount? Right here. I just answered that question. Okay, how do y'all feel about that? Does that part make sense? Okay. We have just a little less than 30 minutes, about 26 or so. So I'm going to pass out your paper. Your lesson 58 begins on 4:02.